Hey guys, we were so close to getting that lesson in the allotted 15 minutes for our videos. Didn't quite make it, so we need to finish up just the final two questions here. Whenever the video stopped, we were talking about question B, which said we had 12 gallons of gas, and then we consumed 10 1/8 gallons of gas. And I've actually got some number lines here, so let's pull a number line out, and let's do it on the number line. So if I have 12 gallons of gas, I'm going to represent that with a vector of 12 to the right. It's a vector of 12. And it says we're going to use 10 1/8. So go back to that strategy that I have been sharing throughout the lesson. I'm going to go 10. That gets me to 2. But I still need to go 1/8. So I'm going just a little further. And that's going to cut in between 1 and 2. And that's going to be at 1 7/8. 1 7/8. So that would be our answer. Now, traditional algorithms work for these as well. Like you're supposed to use number lines, but we could definitely do 12 plus negative 10 1/8. We could look at that as subtraction if we wanted to. We could subtract 10 1/8. We could think about this as decomposing. 12 plus, if this is negative 10 1/8, that's negative 10 and it's a negative 1/8, right? So like we could add these together. 12 and negative 10 is 2 plus a negative 1/8. So that means we're going to take away 1/8 from 2. We're adding a negative 1/8. We're taking that away from 2. So that means I'll have one whole left over, and the one that we're breaking an eighth off of, just think metaphorically, will now only have 7/8 left. We can kind of picture that. We could draw it out if we needed to, but I think that's your next lesson, actually. So, 1 7/8. All right, the last problem here. This one actually would work best with a vertical number line. Let's just turn one of these sideways and make it vertical. It says a fish was swimming 3.5 feet below the water surface at 7 a.m. That's negative 3.5. 4 hours later, the fish was at a depth that is 5.25 below where it was. Okay, so it's going an additional negative 5.25. So now, what is the position of that fish? Well, like I said, this would look nice on a vertical number line, like if this was sea level, right? And the fish is at negative 3.5, so it's going to be down 3.5. And then it continues. We could even, let's draw our fish. Let's make this, here's a little fishy. All right, I've got a fish. Now later he's going to swim down 5.25. So we need to go 5. That's going to put us, we're between 3 and 4, so now we're going to be between 8 and 9. If I go 5 more. And we're supposed to go an additional 0.25. So 5 gets us to negative 8.5. We go an additional 25 hundredths gets us to negative 8.75. Here's our happy little fish down here. There we go, there's our fish. So now he's at negative 8.75. We could also use traditional algorithms like we talked about in the previous problem. Think about that as negative 3.5 plus negative 5.25. And we've talked about integer rules. If both numbers are negative, I can just add these together and keep the sign. Like I know they're going, just add them together, and I know that the sum is negative. So right here I need to fill this place value. So 5/10 is 50 hundredths. That's the same thing. 0 plus 5, I have 5 hundredths. 5 plus 5/10 and 2/10, I have 7/10. 3 and 5, I have 8. This is 8 and 75 hundredths. It is negative because both values were negative. So here we go, negative 8.75. You could use a traditional algorithm if you wanted to, but it's real nice to see it on this number line, especially when you have the pretty fish pictures in there. You're welcome for all that beautiful art. All right, guys, thank you. Have a good day.